Hello, my name is Christina Burgess, and I'm a participant in Challenge 2016. Today we're going to be solving three problems involving limits. Our first problem here is to solve the limit of f of x as x approaches 0 of sine of 5x over the sine of 4x. So here our first step would be to multiply by 5x over 5x. So then we will have the limit as x approaches 0 is 5x times sine 5 of x over sine of 4 of x times 5x. So next we're going to multiply by 4x over 4x. So then our problem becomes limit as x approaches 0 of 5x sine of 5x times 4x over 4x, well, I'll put 5x first just to keep consistency, 5x times the sine of 4x times 4x. So here in these first two steps, all we have done is multiply by 5x over 5x and multiply by 4x over 4x. So here in this next step, using some properties of limits, we're going to separate this fraction into three limits. So here we're going to have the limit as x approaches 0 of sine of 5x over 5x times the limit as x approaches 0 of 4x over sine 4x times the limit as x approaches 0 of 5x over 4x. So here, based upon our limits, properties, and just basic limits, we know that the limit as x approaches 0 of sine 5x over 5x is equal to 1. And we know that the limit of 4x over sine of 4x as x approaches 0 is also 1. And we know that the limit as x approaches 0 of 5x over 4x is equal to 5/4. So therefore, we can just multiply all this together. 1 times 1 times 5/4 is equal to 5/4. Therefore, the limit as x, the limit as x approaches 0 of sine of x, sine of 5x over the sine of 4x is equal to 5/4. So the next problem we have to solve is the limit as x approaches infinity of 2 plus the square root of x divided by 2 minus the square root of x. So the first thing we can do is first rewrite this problem as the limit as x approaches infinity of 2 plus x to the 1/2 power over 2 minus x to the 1/2 power. Now since x approaches infinity, we can use a specific property of limits. So we know that as x approaches infinity, we can look at the degree of the x term. Here, since both of the x terms have the same degree, which is the 1/2 power, then we can say that the limit as x approaches infinity of these is equal to the ratio of the coefficients of the x term with the highest degree. So here, our x terms are x to the 1/2 over negative x to the 1/2. So here the coefficients of our x's are 1 over negative 1. Therefore, the limit as x approaches infinity of 2 plus the square root of x over 2 minus the square root of x is equal to 1 over negative 1, which is equal to negative 1. Now here's our last problem, and with our last problem we were given this function f of x equals the square root of x, and we're asked to use a limit definition in order to find the derivative of f of x at x equals 1. So here we will use the definition of the derivative, which is the limit as h approaches 0 of f of a plus h minus f of a over h. So now we can plug in 1 since we're doing f of 1, the derivative. So the limit as h approaches 0 of f, so a is going to be 1 in this case, minus f of 1 over h. So now we can plug in what our f is. The limit as h approaches 0 of the square root of 1 plus h, because f of x is our square root of x, and f of 1 will be the square root of 1. So we have the square root of 1 plus h minus 1 over h. And here, our next step is going to be to quote-unquote rationalize the numerator. And how are we going to do that? Well, we are going to multiply this by the conjugate of the numerator over itself. So here we would multiply the square root of 1 plus h minus 1 all over h by the square root of 1 plus h plus 1 over the square root of 1 plus h plus 1. So if we do that, we can realize that this is basically like the factored version of a difference of two squares. So here, the limit as h approaches 0, so the top will be equal to 1 plus h minus 1, which is just h, over h times the square root, parentheses, times square root of 1 plus h plus 1. This is all under h. So here we can simplify these h's and have 1 on the top. And here we can plug in 0 as well. So 1 plus 0 is 1. So the square root of 1 is 1, plus 1 is 2. Therefore, the limit as h approaches 0 is 1/2. Therefore, the derivative of the square root of x at x equals 1 is 1/2.